in the diagram of triangle ABC, sorry, this is Unit 3, Quiz 2, review worksheet, question 1. In the diagram of triangle ABC below, DE is parallel to AB, CD equals 15, AD equals 9, and AB equals 40. Okay, so we are looking for DE. It says, what is the length of DE? Okay, and DE is parallel to AB. In this case, right, AB is an entire side of the triangle, so we're going to be working with corresponding sides. We're going to be working with entire sides, okay? So we have an entire side of the small triangle, and we are going to work with the entire side of the big triangle, okay? So small triangle, there's 15, and we have X here. And then we have a big triangle. And so this is CDE over here. And this is C, and this is A, and this is B. And CA equals 24, and AB equals 40. So I like to have X on top, so I'm going to do X. And you could stay in the same triangle if you want. X is 2, right? 15 as 40 is 224. Okay, we're going to cross multiply. And 40 times 15 is 600. And now we're going to, right, we end up dividing it because that's equal to 24x. So let's divide 600 by 24. And that equals 25. So DE is 25. We divided both sides by 24. Boom. X equals 25. Okay. Let's take a look at number 2. Okay, as shown in the diagram below, A, B, and CD intersect at E. Okay, so we know vertical angles, and AC is parallel to BD. Okay, given triangle ABC is similar to triangle BED, which equation is true? So something I want to point out is sometimes it's really hard to see what's corresponding. So what I really like to do, right, is, okay, these are parallel, so this is congruent to this, alternate interior angles, and this is congruent to this. And I'm actually going to erase out the vertical angles just so I could see better. So now if I was to draw these triangles, and I actually okay, I'm actually just going to move this over. Okay, so I have one triangle that is A, C, and E, right? And my little triangle I'm actually going to turn around just so you can see that, right? My longer side. Okay, my longer side. Actually, want to kind of draw it in the same style as Okay, so this is E. Okay, and A corresponds with B, and C corresponds with D. Okay, so now you're starting to see. Do you have to do it this way? No, but it makes it a lot easier to see what corresponds with what. Okay, so it says which equation is true. So we have CE is to DE, okay, as EB is to EA. So here's the thing. This goes big over small, and then it goes small over big. So it can't be this. It doesn't follow the same pattern in the ratio. Okay, then we have AE over, right, BE. And we have AC over BD. Now we're talking. Okay. So in this one, we have AE, that's big, over BE, that's small, and they're corresponding, right? Big over small. Then we have AC over BD, and that's big over small. So your answer is 2. Okay. And you're more than welcome to check the rest, right? The rest would show, oops, that was impossible to do. Okay. So we have AEC over AE. So big is to another side of the big, as BE is to ED. Okay, so that, let's check this out. So we have this side is to this side, right? And so EC is on top, AE is on the bottom, right? DE should be on top, not BE. DE, because it's the corresponding sides, it has to match. ED over EC, ED over EC, right? Small over big, and then we have big over small is not going to work. So 2 is the answer. So in the diagram below, GI is parallel to NT, and IN intersects at GT at A. Okay. So which method can be used to show that triangle ANT must be similar to triangle, and this is a mistake here, this should be, right, AN. So I know this because I can use my angles. Okay. So we have A and T, and then we have A, and it should go to GT, GI. So triangle AGI. Right? Because the corresponding parts should match. Okay. So we know we cannot use, whoops, sorry, girl. You know we cannot use, well, this is similar triangles, right? So similar triangles, we only have angles, so why would we look at anything that has sides involved, right? Hypotenuse, like side, it has to be angle, angle. We're only given angles, right? We're given that this intersects, and then once we know that these are parallel, we could tell that these are angles that are congruent. Okay, in the diagram below, triangle ABC is similar to triangle DEF. Which statement is not true, right? Angle B is congruent to, that should say angle E. Okay, that's true. So AB is to DE. All right, that's big, small over big. As BC is to EF. Okay, that's true. So it's not that one. Let's look at the third one. Third one, we have AC is to AB as DE. Nope. Okay, AC is this side, so it should have this side on top. Okay, so number 3 is not true. Okay, AC over AB, then it should be DF, but it's DE. Okay. And I know it looks confusing because you really want to say this because what is all this? But this is just, the corresponding sides added up. It has the same relationship to the corresponding sides added up. That's true. Okay. In triangle ADC below, EB is drawn such that AB is 4.1, AE is 5.6, BC is 8.22, and ED is 4.42. Now, I know that automatically, like, you see a triangle and you see a cut and you want to use, right, split triangle theorem, right? And you want to put part over part, but this line is not parallel. If it is not parallel, you cannot use that theorem. So they are similar triangles, but you have to separate them correctly. So if you look, this line, wait, so hard to draw. This line of the small triangle corresponds to this line of the big triangle. So I'm going to try to draw this. And I want to see if I could actually just pick it up and move it. Okay. Now I want to draw this. And now you can see, right, the two triangles happening here. I'm going to move this over. Okay, so let me just label these. This is A, E, B, and this is A, D, C. And you can start to see now AE and AC correspond, right? And AE is 5.6, AB is 4.1. And so AD is 5.6 plus 3.42. So we have 9.02. And then we have 3 point, and this is 12.32. Okay, and is ABC similar to ADC? And explain why. So we know angle A is congruent to itself. Okay, so we have, right, 9.02 over 12.32. Let's see if they are equal to, right, 0.1 over 5.6. So let's see if they're proportionate. Okay, so I cross multiply, and we have 9 point times 9.02 times 5.6, and that's 50.5. Okay, and then we can cross multiply 12.32 times 4.1. Sorry, 12.32 times 4.1. And that gives me 50.5. Okay, so these two sides are in proportion, right? And we have an angle A, right? Angle A is congruent to angle A by reflexive property. So we have, okay, sides AD over AC, right, is equal to AE over AB, right? So we have two sides that are proportional, right? And the angle between these sides is congruent. By reflexive property. Okay, so sides AD over AC as congruent. I don't want to use proportional, I want to use congruent. So their relationship the relationship of those sides are congruent to the relationship of these sides. You could even use the equal sign, but I like to use congruent. Okay, so ship of the relationship of AD over AC and AE over AB is proportional, and the angle between these sides is congruent. Okay, so, right, therefore, right, triangle ABE is similar. Triangle ABE is similar to triangle ADC by, right, side angle side similarity theorem. Similarity theorem, okay, which says that if you have two sides, right, proportionate, and the angle in between the two sides of the triangle is congruent, then the triangles are similar. Okay, question 6, in triangle ANT and ELM below, AN is 6, NT is 5.6, TA equals 4, EL equals 9, LM equals 8.4, and ME equals 6. Are these two triangles similar? Explain why. So we're not given any angles, so we have to work with the sides, and we have to check to see, well, is these two sides in proportion to these two sides? Then we also have to check to see, well, are these two sides in proportion to these two sides? That's only two sides given to us, okay? Then we have to check to see if these two sides are in proportion to these two sides to give us side, side, side triangle similarity theorem. So let's start with, right, this side over this side, just to start. And we have is 5.8, let's say, over 4. Is that equal to 8.4 over 6? So we have 5.8 times 6, because we cross multiply, which is 34.8. And is that equal to 8.4 times 4? Okay, and, ooh. Oh, this should be 5.6. I'm like, why wouldn't that come out equal? That's definitely supposed to be equal. So let me fix this. This is supposed to be 5.6, not 5.8. Okay, so we have 5.6 times 6, and that's 33.6. And we have 8.4 times 4, and that's 33.6. So these two sides are in proportionate. So let's try another two sides. Let's go with these two sides. Okay, so we have, right, 6 over 4, 6 over 4, and 6 over 9. I did something wrong here. Okay, so 6 over 4 would, I'm going to do 4 over 6, but I could have done 6 over 4, but I made a mistake in the next order. So I have 4 over 6, right? 4 over 6 is equal to 6 over 9. Okay, I knew automatically when I was doing the cross multiply and it was wrong, something was up. 4 times 9 is 36, right? And 6 times 6 is 36. These are proportional. Okay, proportional and proportional. So let's try the last 3 lines. And we have, right, these two. And we'll do 5.6 over 6 is equal to 8.4 over 9. That should be a 4. Okay, and then we have 5.6 times 9 equals 50.4. And 8.9 times 6. And that's, whoops, something went wrong here. Wait, this should be 8.4, sorry. 8.4 times 6. And that equals 50.4. And remember, this is supposed to be a 4, not a 9. Okay, so we have side, right? Side, side is proportional to side, side, side. So over here, we have, right, n. I like writing this as a fraction because there's so many of them here. So let me see if I can do that. All right. So see if I can put that here, and it moved back there. So let me see. All right, I'm just going to get rid of some of this because I need the space. All right, so we have NT. Well, we did TN over TA equals, right, ML over ML over ME. And ML over ME is equal to and then we have, so we did this side over this side, this side over this side, okay, comma, TA, right, over NA, and we have ME over LE. I know it's a lot, but you know, you guys aren't using a computer. You're able to write this stuff, right? And our last one was TN over LE. And ML over LE. I had TN over NA, sorry. NA and ML over LE. So TN over NA, ML over LE. Okay, it's much easier when you're writing it because you can see each time you're writing it. It's a little harder when you're typing because you have to find each thing. But okay, so we have side. So we have triangles. The two triangles are congruent. Or not congruent, or similar. Triangles are similar, right? Because of the side similarity theorem. Okay, and this says that if all the sides are proportionate to each other, then the triangles are similar. So question 7, this is the last question. Okay, it says to determine whether the two triangles are similar by angle similarity. If yes, write a similarity statement. So we have to use triangle sum theorem to find the last angle, and we do that by doing 180. 180 minus 106, right? And we're also minusing 29, or you can do 106 plus 29 and then subtract that from 180. 180 minus 106 minus 29. All right, and so we're left with 45 here, and that's what we have there. We have 45 plus 29, and this must be 106. Okay, so we have triangle, I'll just call it HES. S is similar to triangle. Now remember, the corresponding parts have to be in the right order. Triangle F, right, 45. H was 45, F is 45, E is 106, N is 106. Okay, S, and that's A. Okay, so they are similar by the angle similarity theorem. Okay, all the three angles are congruent. So triangle HES is similar to triangle FNA, right? By angle similarity theorem. Okay. All right. I hope that this was helpful. Good luck on your quiz tomorrow.